Origami is the art of folding paper. Simply holding a piece of paper, making some folds and getting a shape, just like the paper planes, boats, and even the fans we used to make. When making any fold, it's either of two types, mountain fold or valley fold. Trick is, a fold is both valley and mountain, just depends on which face you're looking at. The orientation. When making a shape just like this, if we flat and fold it, we will find the main folds that create the shape. This is called a crease pattern, and it's formed with the joint of folds connected within the 4 rules of origami design. When folding a crease pattern of a shape, it simply makes the base for it. With a few more folds we obtain the shape we need, like this dragon here. This made this. With some folds, we could reach the basic tips for body, wings, head, legs and tail. Folding a crease pattern takes long time and can be tricky to come up with neat, proper, sharp folds. And at the same time, it's crucial when it comes to the design process and iterations for new shapes, or folding complex models or making curved folds too. Designing a device that would indent the folds or crease patterns on paper that can later on be hand folded to shape, I started the whole design process. Hey, the whole presentation is 5 minutes, no time for that. Anyway, so I started looking into the folding mechanism, the indenting tip and force applied to it, thought about the turnover mechanism and the flooring material as well. Firstly, I had several ideas for the folding mechanism. Thought of using beaded rollers to make the indentations, but had a problem with the crease pattern adjustability. Though I thought about using an inner coil and localized magnetizing to assort the beads, but longing to have an up and running prototype or product in the end, this didn't seem like a logical route to take, though still being a perfect option for mass production at constant rolls topography. I also thought about designing a cube that would go running over the paper and making the indentations, and really favored this idea, but unfortunately time was of essence. So I discarded the idea along with others that were technically challenging, like using beads to make the folding, or a pivot and moving ground, and found that the safest route was to design a numerical control machine and use it for indentations. So I looked up an open source 3D printer and altered its design to fit my purpose with no need for the heaters and other elements. Then looking at applying the force over the paper and seeking a proof of a concept, I inserted an empty pen to an existing 3D printer to make the folding, but wasn't enough to determine the required load. So I designed this setup to add loads and see the effect of adding load on the indentation along the line, then applied it using a beam of an existing paper cutter and given some really useful data at the different paper weights. So instead of the empty pen tip, I used embossing styli and a spring to apply the required force. Moving on, I started designing the indenting tip fixture to fit on the 3D printer used, and thinking about the servo motor, I designed a whole new carriage. In parallel, getting the feedback to make the Z movement manually, I designed a fixture to be added to the existing carriage, which had a problem of adding an extra fold in the movement through the several lines. Then started some runs to try the indenting, and implementing the software part, it was an up and running system. The whole process is all about exporting the DXF crease pattern from Oripa software to the DXF to G-code converter while uploading it to the machine using an SD card to run the indentations, and within few minutes you have your pre-folded shape. I used a cutting mat for the flooring material as it was not metal hard nor sponge soft, giving an adequate reaction for the paper, making just the perfect indentation. For the turning over mechanism, it was decided to be manual and guided also to fit the time window available, although there were a lot of ideas within this area, like using a roller or a robotic clamp. Finally, came to designing the body for the frame, which was very useful not only to accommodate everything within, but also to prevent the relative movement of the whole system to the indenting stylus, also giving the user a window to watch the process while having a comfy ergonomic angle for the interface used. And that's in brief how my major project turned into the beautiful origami indentation printer. Thank you.